Okay, so we're going to find the variance of a discrete random variable on this rainy night. So, if the random variable x has outcomes x1, x2, all the way up to xk, with probabilities p of x1, p of x2, all the way up to p of xk, then the relative frequency distribution given by this table is called a probability distribution. And to find the variance of that random variable x, denoted var x, we say that var x is equal to x1 minus the expected value of x squared times the probability of x1 plus x2 minus the expected value of x squared times the probability of x2 plus all the way up to xk minus the expected value of x squared times the probability of xk. So basically what we're doing, we're going to find the expected value first. Then we're going to take each of the individual x values, subtract the expected value from them to find the deviations. We're then going to square those deviations, multiply those squared deviations by the probabilities, and add them all up. So we're not going to do all that by hand. We're going to use Excel. Reading on, it says that the symbol sigma squared may be used in place of var x, and the standard deviation of x is labeled as sigma. It's the square root of the variance. So if we find this variance of x, the square root of that number will be the standard deviation of x. Alright, so let's take a look at this question here, question 7. And so I'm going to go to Google, go up to that waffle, open up Google Sheets, and then I'm just going to open up a blank sheet. Alright, let me zoom in a bit here. Alright, zoom to 200%. Alright, so I have here some scores. So I'll put scores. And I have the probability of getting those scores. P of x, or the probability of scores in this case. So let's see. So we have the scores and we have the probability of getting those specific scores. Alright. So the probability or the scores are 67, 68, 73, 79, 80, and 83. So those are some scores maybe on some tests. And those are the specific discrete values that were achieved at these percentages. So of the total number of people, 31% received 67 or scored a 67, so that's 0.31. And then 9% scored a 68. And then 40% scored a 73. 8% scored a 79. 1% scored an 80. And 11% scored an 83. So those are the probabilities, and those are the scores in the first column. So probabilities gone, scores down. So now I need to find the expected value. So to find the expected value, I do need to multiply the scores by the probability and then add up all those products. So this is going to be the scores times the probabilities of those scores. So asterisk probability of those scores. Alright, so let's see what we get. We get this is equal to this column multiplied by that column, yes. So asterisk this column, enter. And then it asks me if I want to fill all the ones underneath, and I do. And then underneath here, I'm going to type equal, and it's asking me if I want to just add all those up, and I do, so I press enter. This is the expected value. This number here is the expected value, E of X. So this number is the expected value. So in the next column then, because I remember the formula here, the formula needed to have each individual value had this expected value subtracted from it, and then that difference or that deviation was squared before it was multiplied by the probability. So that's what I need to focus on. I need to take each of the individual x values, let's put it up here. I need to take each of those individual x values, subtract the expected value of x from them, expected value of x, and square that. So that's what I'm going to do in this column. So I'm going to type equal, and then I'm making a parenthesis. I'm going to take the individual score, and I'm going to subtract from the score, so minus the expected value. Close that parenthesis. Now, when this thing scrolls down, I want it to stay on the 8th row, so I'm going to put a $sign in front of the 8 so it doesn't go beyond the 8th row when it scrolls everything down. And then that's the value minus the expected value, and then we're going to square those deviations. So the value minus the expected value squared, or value minus expected value squared. And then it asks, do I want to fill all of those by doing that same thing? And yes, I do, except for that last one. That last one doesn't make sense because I'm doing that with the expected value. So that cell I'll clear out. These are the squared deviations. The value minus the expected value squared. So to find the variance, I need to find the product of these squared deviations and the probabilities, and then I need to add all of them up. So that's what's going to be in this next one. It's going to be the squared deviation, which is x minus the expected value, the whole thing squared. But then I'm multiplying now by the probability of x, which I guess I've abandoned the scores. This should have been scores if I was being consistent, right? Scores, and this should be for scores too. So yeah, if I'm being consistent, this is the expected value and the variance of the scores. Okay, so I'm gonna just take basically this column and multiply it by the probabilities over here. So this is equal to the squared deviations multiplied by the probability of getting those scores. And then it wants to know if I want to fill it all out. Let's go ahead and do that, but this last value doesn't make sense. All right, so there we have the product of the squared deviations and the probabilities, which is exactly what the variance is asking us to do. We take the value minus the mean, square it. This is the squared deviation. We multiply it by the probability, and then this means to add that all up. That's what we're in the process of doing. We're going to add them all up now. So this is equal to the sum. And yes, I want to sum up E2 to E7. I'll take your suggestion. 27.3444. Yeah, so when I come over here and it's asking me to round this thing to one decimal place, that would be 27.3. So 27.3, and there we go.